So this is part 2 of the paper 2 warm-up video for 2016. I'll just scroll through to get to the end of the titration question where we got to last time. And here we go. So I just need to add one detail which was in the question, that we took 10 centimetre cubed of sulfuric acid and we titrated that against sodium hydroxide. And the first question asks you to calculate the amount of moles of sodium hydroxide in 16.7 centimetre cubed of a 0.1 mole per decimetre cubed solution. Now, in order to do that, you need the equation moles equals volume times conc, or you need your triangle, moles, volume, concentration. And so moles is vol times by conc. You use 16.7 centimetres cubed and you times it by 0.1 mole per decimetre cubed. Now, just before you type that into the calculator, hold on, because your volume needs to be converted from decimetres cubed into what we've got, centimetres cubed. So you need to divide 16.7 by 1,000, and that ends up with 0.00167. And the next question, so that's the, well, just before we go on, that's the moles of NaOH. The next question asks you to work out the moles of sulfuric acid. Now, here you can see we've got our ratio at the top. So if I had 2 moles of sodium hydroxide, I'd have 1 mole of sulfuric acid. So that's a 2:1 ratio. So we would have half the amount of sulfuric acid compared to sodium hydroxide. So if your moles of NaOH is 0.00167, your moles of sulfuric acid is that divided by 2, half that amount. And if you just type that into your calculator, you get 0.000835. And to finish it off, we need to calculate the concentration of the sulfuric acid. So here we've got our moles of sulfuric acid. We know that we took 10 centimetre cubed of sulfuric acid. I'm just going to write to the side because it's difficult writing at the bottom on this screen. So I'm going to say conc equals, and we'll use the triangle again, so it's moles divided by volume. So you might think it's 0.0000835 divided by 10, because that was the volume, but also remember that the 10 has to be converted into decimetres cubed again. So it'll be the 10 divided by 1,000. And if you type that into your calculator, you should end up with 0.0835 moles per decimetre cubed. So that kind of question, they could have given to you just in one. They could have given you the intro with the right proportions or the amounts, and then said, calculate the concentration. Helpfully, they have broken it down into 3 stages for you, which usually is helpful, but for some students, they actually find it easier when you just have to calculate the concentration outright. Okay, on to the next question. So you can see this is an organic question, and we're working through a series of reactions, effectively producing a polymer from sugar. So we're producing polyethene going all the way back from sugar, which is quite impressive. So we've got a series of steps. So maybe before we start, it might be worthwhile actually working out the formulae of our products here. So ethene is C2H4. You should remember eth only has 1 carbon, and ethene is an example of an alkene, and ethanol is C2H5OH. Now, to produce ethanol from sugar, hopefully you can remember doing that in the laboratory. You dissolve the sugar in water, warm it, make sure there's some yeast in there, make sure there's not very much oxygen that can get in, and that reaction is called fermentation. And you'll notice that in reaction 2, between C2H5OH and C2H4 over here, we've lost some atoms. Now there were 6 hydrogens in ethanol, there's only 4 in ethene. So that means we've lost 2 hydrogens. We've also lost an oxygen. So we've lost 2 hydrogens and an oxygen, which is water. So we've removed a water from the ethanol. So reaction 2 is actually a dehydration reaction. And reaction 3, well, that's where we take an alkene and we turn it into a polymer. And hopefully you should remember from your notes that that is an addition, polymerization. And I've already mentioned some of the conditions used in fermentation. So you want to use temperatures of 30 to 40 degrees C, no hotter, otherwise it denatures the enzymes in the yeast. Okay, the enzyme is zymase. And a third condition you might like to add is you dissolve the sugar in water. It won't work otherwise. So, a chemical equation for reaction 2 is quite straightforward. Now we've talked about what's going on in there. So we take C2H5OH, we're turning it into C2H4, and I said that we were kicking out a water, H2O. It now asks for the displayed formula of ethanol. Now remember, with a displayed formula, you need to display all the bonds. So we're going to have a 2-carbon backbone, and we put hydrogens, 3 hydrogens off there, another hydrogen there, another hydrogen there. We've still got to do something with our oxygen, so let's put it off there, and that would be bonded to another hydrogen. Now, some people are tempted to write the OH together without showing the bond in between. Try and avoid doing that if you're asked for the displayed formula. The displayed formula wants every single bond to be shown. Notice that each carbon has 4 bonds, and I've drawn these at slightly odd angles down here because of the problem with the bottom of the screen. Now, this question is asking us about turning ethene into polyethene. It follows on from the last question on the previous slide. So we need to have a think about how that happens. So if we have a look at ethene, C2H4, we can see it has a double bond. And when the polymerization occurs, the double bond breaks. So it leaves a single bond, and you can see that the carbons now only have 3 bonds. The carbon is desperate to form a 4th bond. Now, because you're doing this reaction with a great number of these ethene units, you'll have lots of ethene molecules, all desperate to form that 4th bond. So here's another one over here. And what happens? Well, they form bonds between them. So you can see that we link the units together to form a long chain. Now each carbon has 4 bonds, apart from, the ones on the end. And you might think, well, what on earth goes on with those at the end? Well, they just link to other ethene units. Remember, this is just a very short section of what really happens. So here's one ethene unit, 2nd, 3rd, and there'll be a 4th over here, and another one over here, and another one. And eventually, at the very end of the molecule, there'll be an atom bonded at the end where the chain stops. But you don't need to worry about that. You just need to worry about the chain. Now, it's quite rare these days for them to ask you about nylon, but here is a question about nylon, and you need to know the type of polymerization which nylon is produced by, and it's produced by condensation polymerization. And the big difference between condensation polymerization and addition polymerization is that condensation polymerization produces a small molecule as well as the polymer. Addition polymerization only produces the polymer. Okay, so most people say this small molecule is water, and 9 times out of 10 it is water. Occasionally it's something like hydrogen chloride. So you'd probably get away with saying it produces water as well as the polymer, but I'd prefer that you said produce a small molecule as well as the polymer, whereas in addition polymerization you only produce the polymer. And that concludes part 2 of this video. Part 3 is still to be made. I'll get on with that in a minute.